Good morning.
Good morning.
Good morning, guys.
Good morning, sir.
Sir, good morning.
Who appeared for oral a few days back? Tony, you?
Yes, sir, I appeared, but I did
Which
not get
which function?
motor and MEP, sir. Motor and MEP.
Okay. What all question they asked in motor MEP?
First question was, suppose if the turbocharger vane is broken and came to air cooler side, then
No.
what will be my action?
So this question was okay. You can answer this question, right?
No, sir, no.
What was the problem? What you told them? What about other motor MEP
How can?
already clear?
No, sir.
No. So
This
I'm just asking so that you guys also know what all question they are asking. So what answer you gave for this one?
Sir, then in between that, he asked me how to find out. I told him vibration. Then
Okay.
he started asking what type of vibration, how many types of vibration. Then again
Okay.
he came back. uh, Other method of finding out the vein went to air cooler. I told him many things, but he was not accepting. Then whatever, if I tell one word, he's asking just cross question.
Okay. Did you told
He's
about
going
turbocharger surging?
turbocharger searching. No,
You
no, sir,
said
no.
so that
No,
is
sir,
what he
no.
was looking for. Why
Okay,
turbocharger will
turbocharger.
surge?
Because load fluctuation will be there.
Not load fluctuation.
Means
It will be
that,
able to generate less pressure, right?
yeah, less pressure.
So what will happen? Air will backflow from the scaven side to compressor side. I
Also, the
guess.
vein is okay. The he is telling vein is in air cooler.
Yeah, it's okay.
One of the vein is in.
It's in air cooler. So chance, how much is the vein? Very small, right? Very small.
Yes, sir. Yes.
And maybe by saying that he want you to convince on that your air is not flowing to the scaven side, right? Because your air cooler got choked, right?
Yeah, I
So there
told him
is
any answer.
more chance of surging. That's why he is giving you
Okay.
idea by saying that your vein is being into the what we call air cooler, and now your
Okay.
air cannot flow more than air cooler, right?
Yes, sir.
Air is just at the inlet of the air cooler. So what will happen? Surging, right? I
Yes,
think that's what
surging.
he want to listen, and you didn't said surging. You gave lot of
Surging,
answer,
I did
but you
not tell.
didn't. Yeah, you gave lot of answer, but you didn't said surging.
Yes, sir. I did not tell surging.
Yeah. Anything else?
The next one is how to take touchpad clearance. That he
Respect.
want
Hmm.
touchpad clearance. That he want from according to manual only.
Yeah, there is
Whatever.
one gauge which you push inside your thrust bearings.
Yeah, but he want from starting. Open the from
Yeah,
enclosed
there
extend ring,
any
opening
yeah
everything.
any question you have to go from the starting only, right?
But I started telling from the starting itself. But then there is one course question. Where is exactly it is fitted? Where it is fitted? I told him
Where is
outside of
thrust
the
pad
engine.
fitted?
Yeah, I told him outside of the engine, in
Yeah.
between the thrust collar. But he was not agreeing. He wants some other thing.
So you told clearance. He was agreed on clearance, but he didn't agree
No.
on.
Yes. I told him clearance, we have to push it, but
Yeah.
he was not accepting. He was not accepting. He's telling, have you read the manual? You have to tell according to the manual.
Okay. What was the third question?
Um, then regarding the jumping clearance,
Okay.
why jumping clearance is provided?
So why it is
Protect
provided?
Jumping clearance is provided if any force act on the rudder, it will move up, then it may damage the ram.
Okay, Neeraj is having some uh, work at 8 o'clock. So we'll try to do at least one question. We will discuss this maybe later on if you guys want. We'll go to
Yes sir, yes
the
sir,
question. At least he will not waste his full time.
yes.
Sorry. So hello, sir.
Yes.
Sir, can you conduct the class from 7 to 8 because I have to drop my wife morning
Neeraj,
8 o'clock.
everyone had some constraint. Right now we are only three, so you can ask admin if he agree, then okay. Because
Admin,
first of
while we started class that time, he agreed, sir, 7 o'clock to 8 o'clock.
he agreed 7 to 8.
Yes, sir.
Yeah, he agreed 7 to 8.
Okay, I'll talk to him and we'll get it 7 to 8. Okay.
Okay, sir. Thank you.
But again, 7 to 8 problem is sometime regarding the link, right? All
Yes,
of
sir.
we are here, but still no link. Then
Okay, sir. We will call him at 6:40 and we'll 6:45.
okay, I'll talk to him today. We'll see.
Thank you, sir.
He was asking me to take 1.5 hour lecture or 2 hour lecture. We'll see that also how to go about it.
Okay sir.
So a total load of 8,000 kilowatt at 0.8 power factor is supplied by two alternator in parallel. One alternator is supplying 6,000 kilowatt at 0.9 power factor. Find the kVA rating for other alternator and power factor. Find the kVA rating for other alternator and power factor. So what all given in the numerical? Total power factor is given in the numerical. So the total load is given. How much is total load? 8,000 kilowatt. Power factor total is 0.8. Generator 1 power is 6,000 kilowatt and generator 1 power factor is 0.9. What we have to calculate now? We have to calculate kVA, kVA 2 and cos phi 2. So all of you are aware what is power factor, what is apparent power, true power, reactive power. All of you have idea about all this.
Sir, could you just give a outline, then it will be better.
Okay. Please draw the power triangle on your screen. If you want to take screenshot, then take screenshot. Otherwise, draw, and then we will discuss each one of them in detail. This is reactive power. Reactive power we denote with kVAR. Apparent power and true power. Just note down this much, then we will discuss. So what is true power? The power which is actually consumed or utilized in AC circuit. Power is drawn by the resistive circuit, is converted into the useful work. This is known as the true power or resistive power or actual power. True power is measured in watt, kilowatt, megawatt. In DC circuit or in a pure resistive AC circuit, the true power can be easily determined by V into I. True power is in a resistive circuit is equal to same V into I. Reactive power is a measure in voltage and amperage reactive. Reactive power represent the energy alternately stored and returned to the system by the capacitor or inductor. Although reactive power does not produce useful work, so this is only get consumed in the system. Either it is stored by inductor or capacitor, but actual work done is done by the true power. It still need to be generated and distributed to provide sufficient power to enable the electrical process to run. Apparent power is the vector sum of the true power, which represent the purely resistive load, and the reactive load, which represent purely reactive load.
Sir, here apparent power equal to true power plus reactive power. Correct, sir?
Just let me go back to slide. Apparent power is given as, this is the right angle triangle. Can you calculate apparent power using right angle triangle?
Pythagoras theorem. By Pythagoras theorem.
Yeah, Pythagoras theorem.
No, apparent power.
Yeah, you can calculate by Pythagoras theorem. No, apparent power equal to under root of true power plus reactive power, right? Please note down the true power. True power or real power. True power is also known as real power, is the power that is actually consumed by the device or system to perform useful work. So it is only the power you are using in the useful work. It is the power that is converted into the mechanical work, heat, or any other form of useful output. And it can be expressed as V into I into cos phi, where phi is the phase angle between the voltage and current waveform. So if we talk about purely resistive circuit, value of phi will be 1, right?
Yes.
Apparent power. Apparent power represents the total power in the circuit. So what was the true power? It include only useful power, right? Like if you want to rotate a pump, so it is only calculating that power. But obviously there will be some losses, right? You cannot generate 100% of the output, right? So it talk about total power which is being consumed by the any of the device, including both real power or reactive power. It is the vector sum of the true power and the reactive power, and apparent power is measured in volt amps. Mathematically, it is represented by V into I. Reactive power is the power that oscillates between the source and the load. So this is the power which we are not utilizing in getting output, but this is getting consumed because there are various things connected between the to start the motor, right? Or to start any machinery, like inductor, capacitor. It does not perform any useful work. So this power is waste. Actually, we are wasting this energy. But it is required to establish and maintain the electromagnetic field in this component. Clear? If you will not make conductor inside your stator of the motor, will you be able to run the motor? No, right? There will not be any electromagnetic force, right?
Yes, sir.
So that's why we have to make this coil kind of form to get the EMF. To establish and maintain the electromagnetic field in the component. Reactive power is measured in volt amps reactive, and its formula is V into I into sine of phase angle. Whereas true power was the cosine of phase angle, right? Clear, guys? We can go ahead with the numerical now.
Yes, sir.
So can you calculate total kVA? Draw the power triangle, right? On the bottom kW, on the vertical axis kVAR. So can you draw find out kVA, total kVA? Total kVA is what? Apparent power, right? Can you calculate total apparent power?
Sir, this given value 800 kilowatt is true power
Tot-
only.
Total
Total is
kilowatt,
apparent.
total power kilowatt is given.
No,
So
I
we
mean
have,
it is
yeah,
apparent power. 8,000 is apparent power or this
total
true
power,
power?
Real power.
true power.
True power.
Yeah. So kVA will be equal to kW upon cos phi from the power triangle.
Yes, yes.
So what will be the value for kVA?
Oh, 10,000.
10,000. Can you calculate total reactive power also?
Yes.
So I mean kVA to kW by cos phi.
kVA equal to K
kW.
upon cos phi. Okay, let
So
me go back to the slide.
sir, here both are 8,000 kilowatt and 6,000 kilowatt. How can you understand whether it is true power?
Can you see in the numerical a total load is if
Yeah,
kilowatt is
8,000
written,
kilowatt.
if kilowatt is written, then what does it signify? What is the unit for kilowatt? For which power? Okay, let me
That
go
is
back to
true power.
the
True power.
True power. But
true
sir, here
power,
one
right?
alternate sub. Yes, then one alternate supply 6,000 kilowatt.
Kilowatt. So again, kilowatt is which unit? Unit
True
for
power
which power?
only.
True power. So what is the problem?
Yes. So which one we can take?
I said we have to find out total. So what is total load, total power? 8,000. And you have to find out kVA for total. So obviously you are going to take 8,000, right? Guys, I'm not getting your doubt.
Sir, doubt is sir, we have to find question. We have to find the kVA rating.
Yeah, this is not the end. Just wait. This is just the starting of the numerical.
Sir, starting only doubt. Sir, true power is 8,000 kilowatt.
True power
But
is
again,
8,000. Yeah.
then again they are telling one alternate supply 6,000 kilowatt.
Yeah.
So what about that 6,000 kilowatt?
Now in the
See,
beginning, beginning we are finding total total apparent power and total reactive power, correct? No? Now
yes.
at the moment,
Yes.
without considering without considering individual generator, total of
Okay,
apparent power
okay.
and total of reactive.
Okay, sir. Okay.
Understood. There are two
Yes,
generators
sir.
running.
Okay.
One is total power generated by the two generators is 8,000. One
Okay.
alternator is supplying 6,000. Obviously, other alternator is supplying how much? 2,000, right?
Yes,
I guess no doubt now.
no doubt.
So can you calculate kVAR also? As per power triangle, what will be the sine cos phi perpendicular upon hypotenuse? What is perpendicular? kVAR. What is hypotenuse? kVA, right?
Sir, can we find it directly here? This VI sin phi.
Yeah, you can find.
I applied like that 6,000 answer coming or
Yeah, 6,000.
only this directly I put sin phi VI sin phi.
VI
Sin phi.
sin phi. Okay, it came out to be
6,000.
6,000. How did you calculate it sin phi?
This cos inverse 0.8, then sine of that answer 0.6 I got power factor. Sin phi.
0.6, right?
Yeah.
Sin
Sin.
square
But
theta plus cos square theta equal to 1, right?
Yeah.
Everyone?
no, sir. But here, sir, they have not given any VI voltage and current. They have not given. So how can we find out this VI sin phi?
This is mathematical, which we learned a long time back. Sin square theta plus cos square theta is how much?
That is 1.
1. Can you calculate sin theta? What will be equal to 1 minus cos square theta
1 minus cos square theta.
under root. So if you are going to calculate like this, you are going to get value of sin theta. It will come to the 0.6, right?
Is here we can give cos theta equal to 0.8, correct?
Yeah.
But VI, we found out
We
the
don't
sin
need
phi.
we don't need VI. So now you have the sin phi, right? You know the sin phi right now.
Yes.
So suppose this is our power triangle. This is our power triangle. Here we have the reactive power. Here we have the apparent power and real power. Okay. And this is the angle phi between the phases. This is our power, what we call phase angle. So now we already know the real power, that is 8,000. We already calculate the apparent power, that is 10,000. So can you calculate reactive power? Or you can just go by the, what we call it, again Pythagoras theorem. AP square equal to RP square plus real power square, right? Can you calculate the reactive power then? Guys, are you getting?
Yes, sir. KV is root of
We are having this
KV square.
power triangle. In this, we know the real power, right? We know the apparent power also. Can you calculate reactive power? If nothing is given, only these two quantities given, can you calculate this in the right angle triangle?
Yes.
You can
Yes.
calculate, right?
Yes.
Hypotenuse square equal to base square plus perpendicular square, right? This is our right angle triangle rule.
Yes, sir. We can calculate.
Clear now?
Yes.
Okay. Now, till now we were talking about total power. Okay. Everything related to total. Now take number one generator. Okay. Now we will talk about number one generator who is generating 6,000 kilowatt and power factor was 0.9. Okay. Can you calculate kVA in the same manner? kW upon cos phi. How much will be the kVA? What is kW now? 6,000, right? What is cos phi? 0.9, right? What will be the kVA value for number one generator?
6,656.67.
6,667, right? Or 0.67, you can take any digit ahead, right? Can you calculate kVAR for number one generator? How much will be the kVAR?
So this KV equal to 6,000 divided by 0.9, correct?
Yeah, because we are talking about number one generator now.
Okay.
What will be the kVAR? Again, sin theta multiply by kVA, right? Sin theta again you can calculate, or you can just go by the Pythagoras theorem in your right angle triangle. What will be the kVAR, guys?
2906.
Yeah, 2905 or 06. So now, can you, okay, this much is finished now. Can you calculate power generated by number 2 generator, real power? What will be equal to? Right? Power, real power generated by number 2 generator will be equal to total power minus power generated by number 1, right? So what will be it equal to? 8,000 minus 6,000. It is going to come out to be 2,000, right? Clear?
Sir, could you just repeat this last position?
In the numerical, they have given power generated by total power generated by 2 generator, power generated by number 1 generator. Can you calculate power generated by number 2 generator? Real power? Can you calculate? Just minus, right? They are saying 2 generator generating 8,000 kilowatt and number 1 generator is generating 6,000 kilowatt. Can you calculate power generated by number 2 generator? No?
Sir, 8,000 minus 6,000.
Yes. 2,000, right? Can you calculate reactive power of number 2 generator? You already calculate total reactive power, right? Minus, you also calculated total reactive power of number 1 generator, right? Total reactive power of 2 generator was 6,000 and number 1 generator was 2905 or 2906. What will the reactive power for number 2 generator?
3095.
3095.
Sir, I didn't understand.
What you didn't understand?
We are finding out reactive power, kVAR. The first generator kVAR, how much is it? Is it 6,000 first generator kVAR? When we
Yes.
find out that, we found out by using VI sin phi equation, right, sir?
Yes. Okay, let me start putting the solution. Maybe you will get more clear then. Just for your reference, I'm drawing the power triangle first. Can you tell me what is the base on the power triangle? Real power,
True
right?
power,
Or
yes,
true power?
kilowatt.
Kilowatt. Reactive power on the perpendicular, right?
Yes.
and its unit is kVAR, and apparent power on the hypotenuse, its unit is kVA. Okay, just draw this much. First draw this much.
Yeah, already drawn, sir.
Already drawn.
Yes.
I hope no confusion in this much. Apparent power equal to total power divided by cos phi from the triangle. Total power is given 8,000, cos phi is given 0.8, 10,000 kilowatt, sorry, kVA. No doubt?
No, no doubt.
Okay. Then we are going to calculate the total reactive power. What will be the total reactive power? Or you can just go with the right angle triangle. What is right angle triangle? You have to calculate kVAR. So we know hypotenuse equal to under root of base plus perpendicular. You can calculate like that also, or you can just calculate like this. Then sine theta you will be able to find out from the cos square theta plus sine square theta equal to 1. So you will get the sine theta value like this. Okay. Any doubt?
No, no, sir.
No doubt, right? Now we will talk about number one generator. So can you calculate number one generator total kVA, that is apparent power? Total power is given as 6,000. Phase angle is given as 0.9, right?
Yes.
Can you calculate reactive power for number one generator? Same like you did for total reactive power. Any doubt now?
No, sir.
Can you calculate power generated by number two generator? We know they told in the numerical total power is 8,000. Power generated by number one generator is 6,000. So can you calculate power generated by number two generator? 8,000
Yes.
minus 6,000. Simple maths, right?
Yes.
Can you calculate kVAR for number two generator? Total minus number one, right?
Yes.
Clear this much? Clear this much?
Yes, sir.
Now I have to rub, that's why I'm asking. I have to erase now. There is no space to write anymore. I'll just try. No, you will not be able to see. Can I rub?
Yes, sir.
Can you calculate apparent power for number two generator? This is just a Pythagoras theorem on right angle triangle, right? Guys, and how to calculate power? Again, right angle triangle. You have to calculate phase angle. So your cos phi will be equal to kW upon K, right? Clear now? And these are the two things they were asking in the question. Clear, guys? Or any doubt? Guys, at least say yes or no.
Yeah, for me, clear.
Tony?
Clear, sir.
Okay. Okay then guys, that's all for today. There is no time for other numerical. See you in the next class, or maybe we'll keep the next class 7 to maybe 8:30 or 9, because some numerical takes a lot of time. Okay.
Sir, tomorrow we'll be discussing problems from another topic, or like,
Like,
I mean, the same type of problem, or we cover another topic. For example, if DC motor, then there are many DC motor questions.
okay, we'll take question on the DC motor. Okay.
No, I mean, I don't know which type of questions are coming more from which topic. So,
There is no such criteria. Normally they are asking 1 or 2 question from the DC motor, but there is no pattern like that. That's why I'm going with the question paper what they are asking in the previous. So I'm just going with the question papers.
okay.
Okay, sir.
Okay. Okay, guys. Thank you.
Okay, thank you, sir.
You both of you are also comfortable with 7 class starting from 7.
Yes, yes,
Okay. And we can go up to maybe 1.5 hour or 2 hour lecture, right?
yes, yes.
Okay, guys.